examples. Okay, but let's just recall what is Fourier series for. So Fourier series for the function where my fx is in the interval minus phi to phi. Okay, so this fx is given by a naught plus summation n equals to 1 to infinity an cos nx plus bn sin nx. Okay, these are called the Euler formula, where the Fourier coefficient a naught is given by 1 over 2 pi over the interval minus pi to pi fx dx, and an is given by 1 over pi over the interval minus pi to pi fx cos nx dx, and bn is given by 1 over pi over interval minus pi to pi fx sin nx dx. Okay, so let's look at another example on how to solve this. Okay, so let's say we want to find the Fourier series Fourier series for the function fx equals to 0. This is called piecewise function. If in this case we have minus pi x 0, and for this one we have 0 x pi. Okay, so this is a question. Now we want to find the Fourier series for this question. Now if you look at it, first before we want to use the Fourier series, because for different series we have different formulas, but in this case you look at the interval is from minus pi to pi. Okay, so therefore we can find using the equation given as this thing. Okay, so you need to find a naught, an, bn, and once you obtain this value, put it into your fx. Okay, so if you look at this equation again, okay, from negative pi, from 0 to negative pi is 0, okay, and then from 0 to pi we have x. Okay, so we want to find a naught. A naught is given by 1 over 2 pi negative pi to pi fx dx. So we have 1 over 2 pi. Now I can divide this interval from minus pi to 0 fx dx plus 0 to pi fx dx. Okay, where when come to negative pi to 0, okay, the fx is given by 0 here, okay, and then plus from 0 to pi x dx. Okay, so continuing, we have, so this is 0. Okay, sorry. So this is 0. Okay, integrate from integrate 0 dx will give you a constant. Okay. Now all we have to do is we have to integrate this interval. So we have 1 over 2 pi. Now integrate x will be x2 over 2 from 0 to pi. So this will give me pi squared over 2 minus 0. So cancel out the pi, we have pi over 4. Okay, so this is for my a naught. Now what we need to do is we need to find an. Okay, let's find. Let's look at an. So I want to copy this this an, okay, an equals to 1 over pi fx cos nx dx. Okay, so an equals to 1 over pi, integrate from negative pi to pi, fx cos nx dx. Okay, so the same case we have to do here. So we have 1 over pi, we're going to integrate from negative pi to 0, 0 dx, plus from 0 to pi, x cos nx dx. Now this is 0, so we cannot do anything in the integral here. Now we can simplify this. So all we want to find is integral from 0 to pi x cos nx dx. Okay, now you cannot say this is odd function, this is even function. Okay, the interval must be from minus pi to pi in order for you to decide whether it's even or odd function. So in this case, we just have to integrate. So we have to integrate using integration by part. This is u, this is dv. Okay, let's u equals to x, dv equals to cos nx dx. So differentiate this, give me 1, integrate this, give me sine nx over n. Okay, now you want to integrate this interval. So have uv minus from 0 to pi v du. Okay, so we have 1 over pi, u is x, v is sine nx over n. This is from integrate from 0 to pi minus integrate from 0 to pi v, which is my sine nx over n, du is 1, so dx. Okay, this is just basic integration. Now for this one I would like to substitute my pi. So I have pi sine n pi over n minus 0, and then minus, now integrate this, give me negative cos nx over n squared. Okay, I hope you are with me. Now simplify this, 1 over pi, pi sine n pi over n. This will become positive. So we have cos n pi over n squared minus cos 0 over n squared. Okay, so simplifying this, you can look at, for n equals to 1, I can say that no matter what value of n here, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, so this whole thing is 0. Okay, now this one on the other hand, okay, so we have now cos n pi over n squared minus cos 0 is 1, n squared. Okay, so there's two ways to write this. So I can write this as, okay, I can write this as cos n pi minus 1 over pi n squared, or I can also write this as minus 1 to the power of n minus 1 over pi n squared. Now the reason I'm writing like this, this is if you look at for any value of n, if n is 1, cos pi, you'll get negative 1. And then when n is 2, you'll have a positive 1. And then you see that this term value here is either -1 or 1 at different values of n. So that's why I can write it at -1 to the power of n. Okay. Now we haven't done yet. We have to find our bn here. So bn will be 1 over pi minus pi to pi fx sine nx dx. Okay, so similar to what we did for our an, now I have, since we know interval from minus pi to 0 is 0, we're just gonna write it from 0 to pi x sine nx dx. Okay, so now we got to integrate this by parts. So let u equals to x, dv equals to sine nx. So du dx is 1, v is negative cos nx over n. Okay, now putting into this formula, we have uv minus v du. Okay, I need to write it in case you don't want to get confused. So u is x, v is negative cos nx over n from 0 to pi minus from 0 to pi v, which is negative. So I'm going to just put positive here. Okay, cos nx over n dx. Okay, now all we got to do is to integrate this and simplify. So when I put pi here, cos n pi over n minus 0 plus integrate cos will give me sine nx over n squared from 0 to pi. Okay, so simplifying this, we have negative pi cos n pi n plus sine n pi over n squared minus sine 0. When x is 0, sine 0 is 0. So similarly, sine n pi is also 0. Now we have this term. So we have negative cos n pi over n. And I can write this as negative cos n pi, always be negative pi to the power of n over n. Okay, so now we have obtained this answer. Okay, depends on what is my bn. So now we gotta do is put it into my fx. So what is my fx? So my fx equals to a naught plus summation n equals to 1 to infinity a n cos